Venus is our closest neighbor, only about 43 kilometers away from the Earth. Venus has always been an object of fascination of astronomers who believe it to be similar to Earth. In 2005, ESA launched the first mission to Venus, and after 8 years of intensive observation, we now know more about this mysterious planet.
Although these studies of Venus had given us a basic knowledge of the conditions prevailing on the planet, but had generated many more questions than they have answered concerning its atmospheric conditions, chemistry, structure, dynamics, surface-atmosphere interactions, atmospheric and geological evolution, and plasma environment. It is now a high time that we proceed from the discovery phase to a thorough investigation and deeper understanding of what lies are behind Venus' complex chemical, dynamical, and geological phenomena.
Venus Express was the first Venus exploration mission of the European Space Agency, ESA. Launched in November 2005, it arrived at Venus in April 2006, and from that point, it started to send information back to the Earth from its polar orbit around Venus. Equipped with several scientific instruments, the main goal of the mission was the long-term observation of Venus' atmosphere. The observation over such a long period of time have never been done in previous missions to Venus, and was the key to a better understanding of the atmospheric dynamics. One of the Venus' important discoveries was the evidence that Venus has been volcanically active in the last 3 million of years, suggesting that there may still be volcanic activity. ESA concluded the mission in December 2014. On Venus, days last longer than years, due to the planet takes 243 days to rotate around its own axis and only 222 days to go around the Sun. Also, it moves in an opposite direction to the Earth, with the sunrise on the west and the setting in the east. Venus has also more interesting features, such as its strange winds that travel up to 400 kilometers in 1 hour, and massive hurricanes over 200 kilometers moving around its poles. All this information about the planet have been generated by Venus Express during its time in orbit.
The mission was proposed in 2001 to reuse the design of the Mars Express mission. However, some mission characteristics led to design changes, primarily in the areas of thermal control, communications, and electrical power. The launch window for Venus Express was open from October 26 to November 23, 2005. However, problems with the installation stage led to a 2-week launch delay to inspect and clear out the small installations on the spacecraft. It was eventually launched by a Soyuz Fiji frigate rocket from Baikonur Cosmodrome in Kazakhstan in November 9, 2005. A first trajectory corrections maneuver was successfully performed in November 11, 2025. It arrived at Venus on April 11, 26 after 153 days of journey. Among the instruments that were used during the mission, the VERA is one of them. The VERA is a radio-sounding experiment that transmits radio waves from the spacecraft and passes them through the atmosphere or reflects them off the surface. These radio waves were received by a ground station on Earth for analysis on the ionosphere, atmosphere, and surface of Venus.
The atmosphere of Venus is the thickest and the most dynamic along the terrestrial planets, and it also displays an unusual behavior. In contrast to the solid planets, the equatorial atmospheres cycle the planet in only 4 days. This is 60 times the planet's rate of rotation. Per kilogram, the atmosphere has more angular momentum than the solid planet. This phenomenon is called superrotation. Is poorly understood. There must be a forcing mechanism that keeps the superrotation against dissipation by friction, and this mechanism is yet to be totally determined.
A common mechanism for slow rotational rates is tidal locking, which occurs when tidal forces from a star or planet force a smaller body to have equal rotational and orbital periods. A superrotating atmosphere could potentially equalize temperatures across these planets enough so that they have conditions suitable for life. The slow rotation of Venus leads to 4 different patterns of atmospheric circulation than any other planet. Venus' slow rotation gives rise to a negligible Coriolis force, thus the circulation is said to be cyclostrophy, balancing the centrifugal force and a pressure gradient.